Tim, did you get it done? Because you were telling me you didn't even think I was asking the right question.
I don't think you were either, but...
How was I not asking the right question?
I talked to State Farm about it. I was saying that you worded the question wrong. I figured out what you're supposed to do.
No, I think it was more clear if you just watched the video again, where you basically told us to do the assignment rather than just blindly looking at the assignment that was up there, which that's not really, I mean, we all have access to the lecture, it's not a big deal.
Yeah.
What was the actual assignment like? I kind of just ignored it and did what he told us to do in class.
I mean, so here's the COD. We're inside of app expression, right? So we're either dealing with a lit expression, a var expression, a lambda expression. Otherwise, it must be an app expression. App expressions come now in 3 different forms. We have something that's already a lambda expression as the first element, or we have something that's an op expression as the first element, which is the new guy, or we must have something that's a var expression as the first element that needs to be resolved to either a lambda or, in the future, probably an op expression, right? Somebody punch you?
No.
His girlfriend makes him beat himself.
You got beat up?
No,
No.
it's from just wrestling.
No.
This is wrestling practice? Gives you black eyes?
Yeah,
Well, if it's wrestling, that still means you got beat up.
not necessarily.
Did you win?
No, I lost by 1
Well,
point.
then you definitely got beat up.
So,
Well, you know, it's
By definition.
You were in a fight. You
I
lost.
used to
You got
wrestle.
black
I know
eye.
this.
You
I
got beat
lost by
up.
1 point.
Wrestle.
Everyone else on the team got lost by 8, 15, or got stuck.
okay, so you were the one who sucked the least.
Yes.
Got it.
But he still got it.
Okay, so homework was to write this piece right in here, right? So if we have an op expression as our first element, that means that we're going to have, what? Op expressions are always applied to how many operands? If I have the plus sign, it's always applied to 2 numbers. 5 plus 7, for example.
Where's Beyonce?
Right? So, if we're going to do this, we probably need to have an eval op expression.
It's up there.
Oh, already wrote it. Ha, look at that. I even gave you like 3/4 of the homework. This is pretty much done.
Skip that. Not even do that.
All right, so here's our app expression. Here's the environment in which it's being built, right? And we know that the first element of this app expression is going to be an op expression. So we're going to be interested in the car of that guy. Is he a plus? Is he a minus? Is he a times? Is he a divide? So are those the only 4 we said we'd support right now?
Yep.
Okay. And then we're interested in the catter and the CADDR of it, right? Of our app expression. Our app expression should have 3 elements in it if it's an op expression. Okay, first element should be, well, actually, the app expression is going to come in. Its very first element is actually the word app expression. Correct? Is that what I'm passing it here?
Well, kind of it's your option. Whatever.
Oh, I haven't passed it yet. Got it.
You basically
So,
said that that's how you're going to do it, but you certainly don't have to.
yeah, you can choose how you're going to call this guy here. So let's call it. We'll pass it the cooter. So when we get to our app expression here, the car of this guy should be an op expression. The catter of this guy should be the first operand. The CADDR of this guy should be the second operand. But both of those guys need to be evaluated. Correct? Okay. So I can go ahead and do, let's just back this up a little bit. So let's create a let. We're going to let environment here. And we're going to let op1 be eval expression CADR app exp in the current environment. We'll let op2 be equal to eval expression CADDR app expression in the current environment. Then we want to do a cond inside this let. So we have now evaluated our 2 operands, right? Might be 5 and 7, might be 2 variables. So it could be a couple of lit expressions, could be a couple of var expressions, could be a lit and a var expression. At the end of the day, it's going to ultimately boil down to 2 things, assuming we've written accurate code, 2 things that we can apply an op expression to. Make sense? All right. And I suppose if we want to fully use our let expression, we can call this guy the op. And we can say that this guy is actually going to be the car of app expression. Like that. So we have 3 different values there now. We can just use them more easily. So let's go ahead and do a cond. So cond the op so EQ the op is a plus sign. If that's true, we're going to boil down to plus op1, op2. EQ the op is a minus sign. Then boil down to minus op1, op2. EQ the op is a times. Then we'll multiply op1, op2. EQ the op is a divide. And we'll divide op1, op2. And we just assuming that's always the correct order. Fair enough. Go left to right, I guess. Finally, we have an else, and we'll just boil down to false. So there's eval op expression. And down here, if we're dealing with an op expression, then we want to go ahead and call eval op. We call it exp or expr. exp. And this guy takes in 2 parameters. He takes in an app expression, so we're going to pass it the cdr of LCE. Is that right?
Yep.
And then we're going to pass it the current environment. Like that. All right, so here's our lambda and example. And this guy's going to take in an A, B, and C here. So A is this guy. B is this guy. C is this guy. And then what are we going to do? We're going to apply A to B and C. So A takes in X and Y. So 5 will come in for X, 6 will come in for Y. We'll add those 2 together, so we should get an 11. Get a false. Oh, does this guy need to be quoted?
Oh. No, because it parses it.
Go back up to apply
Did you
op
pass in-
expression.
Let me look at this real quick. I want to...
That was
Parse it first.
right.
Parse it
What
first.
are you passing in?
I'm just going to check it real quick. We know we're getting there, so let's just see what app expression boils down to. So it boiled down to op expression. Oh, I got to eval the op expression. Or, well, I don't have to evaluate the op expression. I can't just look at the op. I have to look at, it's not the car of it, it's the CADR of it. That guy. I want the plus sign. The car of it's this guy. Right? So now this should give me the... So car of op, this should be the plus. So let's print out the op here.
Should it be the car of the car? Or no?
Aren't you just getting the variables and not actually
It is the car of the car.
numbers?
So the car of this guy is that, car of that guy. So hold on. Car is going to be this guy. That's op expression. So if I want to take the car of that, that's going to give me that guy. So if I take the CADAR, CADAR of that, I get the right value. So there's my 11. So the op, we weren't extracting the operator out of our guy there. So we can still go back and return false. All right, so now our language actually does stuff. So what were you asking, Nick? You were confused on something, so, or it makes sense now. Okay, So we can now do mathy stuff, which then allows us to do complex mathy stuff, right? So can't I then say, put in here, minus y1, for example? So now it should be 6 minus 1 is 5. 5 plus 5 is 10. So now I can start doing pretty complex things with my language now that I've built this into it. So now we have the ability to have lambdas, have things like that, and actually have them apply to things. That's kind of good, right? All right. So what's next? So now we can do some math stuff. What other math things might we want to be able to do?
Do the measurements for a bar.
Legitimately. Huh?
Modulus, yeah.
Mod? Okay, so we certainly can put mod in here. That would be an easy enough thing to do, right? So we can come up here. We want to add mod to this. You want to do it as the percent. So we'll go ahead and add it there. And then all we have to do is add it here. Say if it's mod, modulo, op1, op2. And now we can say y mod 3. So 6 mod 3 is actually a 2 plus 5 is 7. Oh, no. It should be 0. That's the correct answer. 6 mod 3. 3 goes into 6 2 times, remainder 0. So I didn't know how mod worked. Okay. So this comes down to 0. 0 plus 5 is 5.
I was wondering where you're getting that math.
So here, we can do 4. Let's do that. So 6 mod 4. 4 goes into 6 one time, remainder 2. So now this should give us a 7, right? There's our 7.
Great facial expression when you thought that. You're just like, wait, what just happened?
I broke math. Okay. So that's kind of the obvious stuff. We can put more math stuff in there, put sines and cosines and things like that. So let's kind of think farther outside the box. What are other things we might want to be able to do in our language? Or let's go this route. What are things we can now do having pluses and minuses, and what power does that give us? If we were done, if we put the seal of approval on our language right here and we said, okay, well, this language is ready to ship.
Doesn't
Okay.
that essentially give you a way to kind of create a loop? Because you can increment them then?
Okay, well, do we have a structure for creating loops?
Not quite yet.
That would be kind of cool if we did.
Yeah, that'd be kind
Right.
of the next step.
Ah, exactly. So problem here is we have a language now that allows us to do complex nested arithmetic, right? Okay, but what are we going to do with that? Okay, remember, how do human beings solve problems? We remember things. Does our language support variables? It does. We ask questions. Does our language support that? Nope. Repetition. Does our language support that? So why don't we go in order? So maybe ask questions first. Okay. Every single programming language will have facilities for those 3 things. I've said that lots and lots of times in your career here at Concordia. Okay. So is this guy a programming language yet? Almost. It's a third of the way there. Okay. Well, I guess is that almost? In Amish circles, maybe. I guess.
It's like your boat.
Third of the way there, no electricity. That's what we're doing pretty well. All right, so now we need to add a conditional, an if. Okay, we need an if expression. So what does an if expression look like? Let's go back to our keynote here. So this.
0 versus 1 versus 0 versus 0 1 versus 1 versus 1 versus 0.
Is this 470? That's it. All right, so an if expression. So if expression is going to have several pieces, right? We have if followed by what comes, okay, some Boolean expression. Okay, followed by a true expression, followed by, come on, killing me, a false expression. So is this how we can represent our ifs? And that guy should probably parse into if expression, Boolean expression, whatever this guy, whatever this guy ends up being. So let's just put a couple of dots in there for right now. And then we have a sum expression. So this is sum expression, dot, 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 and then some other expression, dot, dot, dot. So it's going to parse into that. Okay, where this is what happens if it's true. This is what happens if it's false. So this is a new guy, isn't it? So we need to have the ability to deal with Boolean expressions. What's a Boolean expression? Something that boils down to true or false. Okay, so let's start off with simple, the simplest Boolean expressions before we come down to evaluable Boolean expressions. What is the simplest Boolean expression you can come up with? True or false. Those are the simplest, right? So right now we have this idea of a lit expression, and all of our lit expressions boil down to numbers, correct? We currently have a language of numbers. So can't we actually now have a lit expression that is actually a Boolean expression? It's a Boolean literal. Does that make sense? So do we treat those? So let's actually come in here real quick and let's see what our, let's gut this real quick. So let's say well, we don't know how to do ifs yet, so let's just do false, true. And then let's just parse that, not run it, since we're not going to be able to run this guy yet. All right, so expression, this is going to be a value, this is going to be a value. When we go to parse this, the very first thing we ask, is it a number? Only a number. All right. So now when we're parsing this, we have to build in the ability to handle something more than just numbers, right? False is not a symbol. So symbol, question mark, false, not a symbol. Boolean, question mark, false, it's true. So new predicate. We have a predicate called Boolean that tests to see if something's a Boolean. All right, so we'll come up here. We're going to say Boolean LC expression. If that's the case, then let's create a list called a bool expression out of our LC expression. So now we have an app expression with two bool expressions in it. So far, so good? All right. So now we need to add to our parser the ability to handle an if expression. Because right now if I just say if in here and I try to run this, it treats the if as if it's a var expression. In modern language, from your perspective of, let's say, Java, what is if? What's the vocabulary word or the phrase associated with something like if? Or like this, or like for, or while. What kind of animal are those? How do we know those are not variables?
They're set aside in the language as something special.
Yeah, they're reserved words. They're something. I mean, you described it perfectly, right? They're set aside by the language as something special. They're off limits. All right. So we have a list of reserved words now. So up top here, we have define list of operators. So now we have define list of reserved threes?
Yeah.
Reserved words. All right, and these guys are gonna, so right now we just have one in here, right? It's a very, very big list of reserved words. We just have the word if is reserved at this point. Okay, so we have our list of reserved words. Now we can also use our contains for checking that, correct? So when we go into parse, if it's a Boolean, do this. If it's a number, do this. If it's a symbol, we're automatically assuming it's either an op expression or a var expression, okay? Because we're asking if it's an op. So now we need to elaborate on symbols, right? It's no longer just an if one thing or the other thing. Now it could be one of three things. It can be a reserved word. It could be a op expression, or it could be an operator, or it might just be a var. Okay, the var is the catch-all. Okay, if it's not reserved in our language and it's not an operator, which I mean you can check those two interchangeably, right? Aren't all operators by definition reserved? But we're going to kind of set them apart in their own little world. All right, so let's change this if to a cond. Let's get rid of this. Okay, so we have a cond. And we're going to say op LC expression. If that's the case, we're going to create a list containing op expression, LC expression. Okay, now we need to write the equivalent for, where's our helper function here? We have op somewhere.
Oh, it's right above parse.
Oh, right above it? Okay, oh, there's op. So define reserved word to be a lambda s and returns contains s in list of reserved words. That guy? And I'm going to steal this because I don't like spelling reserved word. I have trouble with that. Well, I'm lost. What was I doing? Oh, here I am. So now we're going to say reserved word LC expression. If that's the case, we're going to do something else. Okay, we're going to actually build the structure in for this guy. So if that's the case, then we need to go ahead and build another cond based on which reserved word it is. Right now we only have one, right? Okay, so but we need to be able to handle this differently so we can treat it differently. So we'll go ahead and give ourselves the structure for this. So cond EQLC expression if, then we're going to go ahead and create a list if expression. Do we need to include LC expression in there? I don't think so. I think it just looks like that. Right? We can come back and change that if we decide it requires it. So we'll go ahead and just end that cond right there because we're going to add stuff to it later.
Do we put an else in it though?
Do conds require an else? Do they?
No.
Oh, we're going to find out quick enough. So let's if this, once we're done with this, if this screams, considering that I always write perfect code, if this screams, then we'll be fine.
It'll scream if you don't have a valid statement. Like if you don't have one of the. Like if you put in the word
somehow
off.
it gets in there, but it's if, but it's not if, it'll yell at you.
Yeah.
All right. Well, let's just see here for a second. So now we'll have an else to this guy. The else to this guy is going to be a list var expression LCEXP. All right. So we've expanded what it means when we find a symbol. If we see a symbol, we're going to go ahead and check. If it's an op, build an op expression. If it's a reserved word, which reserved word is it? If it's a if expression, then create a if expression. That's it. That's the only possible reserved word we can have. else it must be a var expression. So if it's not an op and it's not a reserved word, must be a var. Make sense? All right. So let's see if this guy screams right now. Oh, I need to quote that.
And then bar.
Good. So, yep, so here's our if expression. And then we have our bool expression false, a bool expression true. Okay, so looks like we're parsing ifs correctly now. Now, right now I'm just saying this guy like this. So now we want to take this a step further. So now we want to say if false, let's just keep it simple, 1, then 2. Something like that. All right, so here's our app expression. We're applying an if to this Boolean. So right now it's our simple Booleans. So if false, that's should boil down to this guy if we do this right, just a 2. Okay. So first of all, is an if a valid app expression? Is it okay to call an if an app expression? We're applying something to some stuff. We already have an infrastructure for app expressions. Might as well keep it. Go ahead.
Quick question for if when we parse it, do we want it to contain the Boolean, right? Because right now it's just stating that it's that. The one that we wrapped around the entire thing.
We could have it, but we're getting it separately. So I think really what we're doing here is we're just saying, what kind of thing should I be applying to the rest of the stuff? I'm applying the if logic, whatever that means, and I'm applying it to these 3 parameters. Okay, so it's a new form of app expression. Make sense? All right, so now what do? Well, we come down here just like we were looking at something being an op expression. Now we're going to look to see if it's an if expression. So let's steal this right here. All right, so if this is true, that means the first element of our app expression is an if expression. Okay, we could call them statements, I suppose, if we wanted to. We'll see if we start running into limitations of this. So for right now, let's just call it an if expression. We'll upgrade it later when it makes sense. All right.
Change it from a val op expression.
Yeah, we haven't written that yet. All right, so now we need to write eval if expression. And what are we going to pass it? We're going to pass it everything but the app expression. Do we need to pass it the if expression part either? Okay, so really we want to pass it the CDDR. So not app expression. We could just burn past the little list that says if expression in it, right? That was just the guy we used to identify. It was kind of a post-it note stuck on it. Okay, so now what we're stuck with is a list that has 3 things in it: a Boolean expression, a Boolean expression, and then 2 other expressions. We don't know what kind of expressions they are at this point, but they're something. Okay, so now we got to write that helper. So this guy evaluates an app expression whose car is an if expression. So we will define eval if expression to be a lambda that takes in an app expression along with an environment. And what are we going to do? Let's see, did I do something funky here? Didn't that indent more than it should have? Oh, no? Yes? Maybe?
Looks right.
Doesn't look right relative to that guy.
Oh, wait.
So let's go ahead and let. And what are we going to let? We're going to let bool expression. Let me kick that down the line. Oh, actually, we can keep it up on the same line. That's what I did up there. We're going to let a bool expression equal eval exp, the car of app expression. So that should give me the Boolean expression portion of that. And I'm going to evaluate it in the current environment. Then I'm going to let true expression be eval exp on the CADR of app expression in the environment. We'll let false expression be eval exp in the CADDR of app expression in the env. Okay, and then what are we ultimately going to boil down to? We're going to say if bool expression, true expression, false expression. Like that. So we'll use schemes built-in if to test our Boolean expression, the value of that, and boil down to either our true expression or our false expression, whichever one of those it was. So this is eval if expression. When we call eval if expression, we're going to pass it the CDDR of LCE, so we'll go ahead and burn past app expression as well as this guy. Neither of those two are required for our if. So we'll be left with a list containing these three elements. A bool expression, and in this case, a lit expression and a lit expression. Make sense? So now, if we run this program, if false 1, 2, we should get a 2 out of this guy. I misspelled lambda somewhere.
Scroll at the top.
Oh,
Very top.
that's why I didn't like the indentation. I was testing you guys and you totally failed. I purposely threw in the misspelling, and then look what I get in return. All right. Oh, I closed my let. Oh, can't do that. Gotta close it here. All right, so if it was a lambda,
When we get the
let's parse this first.
when we get the Boolean expression, we don't need to evaluate that. We're not evaluating.
We don't know how to eval a Bool expression is the issue.
Yes.
We do need to evaluate, we just don't currently know how to do it. So we're not done. We have to teach ourselves how to handle Bool expressions. So inside of eval expression, we're currently handling lit expressions, var expressions, so we actually need to, well, we could steal this line right here. So if it's a Bool expression, for right now we can just return the same thing as we do for lit expressions, right? Just boils down to that value. In this case, it'll be true or false. Later on, Boolean expression could be more involved in that. We'd actually want to evaluate what's in it. So we'll burn that bridge when we get to it. All right, so now we have an app expression. Here's our if expression. Bool expression false, lit expression okay. So let's actually run this program now. And there's our 2. If I change this to a true, we'll get our 1. So now we've added if statement support to our language. All right, except Right now our if statements are a little bit on the weak side, right? We don't really have the ability to build any sort of complex Boolean expressions. That is, we can't say less thans and greater thans and equal tos and stuff like that. We basically just say true or false. It's the extent of our ability. So we have, if we were to continue on with this and build loops, we currently have the ability to have infinite or non-running loops. This is very much a binary approach to loops. We don't have something we can run 10 times. We have something that either runs forever or doesn't start. One of the two. Probably don't want to write loops yet, so we need to expand on our idea of a Boolean expression. So for example, instead of saying something like this, maybe we say if less than, well, let's see, how is our, yeah, we usually do it like this. If less than 3, 5, for example, if this boils down to true, if 3 is less than 5, then do 1. Otherwise, do this. So we should be able to say this again.
What happens if you run that right now?
Let's see. Well, what should happen? This is gonna.
That should boil down.
Well, it's gonna. This is gonna treat this guy as a not a reserve. So this would be a var expression for this guy if we parse it. It won't run it. We'll parse it. So he'll treat that guy as a var expression. And then 2 lit expressions, but we won't know how to apply this guy. Okay? What kind of animal is that, would you say? If we're thinking about Java and I asked you what the less than is, give me a word or a short phrase that describes the less than symbol. Okay? We already have things called operators. Should it be in the category of normal operators? Is this guy a normal operator? It's a Boolean operator? Are all Boolean operators created the same? What's the difference between this guy and like an AND?
What is that or and?
And. Well, in Java, double ampersand or something like that. What's the difference between a less than Boolean operator and an and Boolean operator? Is an and used to boil down to true false?
Yeah.
What would you describe those guys differently?
One's more complex.
And is essentially a true and a false, and less than you're actually dealing with real numbers.
Okay. So does the less than require, in our world right now, numbers?
Yeah.
Okay. And what does the and require?
True.
Boolean expressions?
Yeah.
Okay. So could we call the less than, the greater than, those guys, could we call those Boolean or maybe arithmetic Boolean operators? Something like that?
Can you spell it?
Maybe.
We'll find out.
Define math Boolean.
Define
Math Boolean.
arithmetic
Looks right.
Boolean operators.
I would have totally just shortened that to ops.
Well, I wanted to match it to what we have above there. We're kind of at the point in time now in our interpreter as it's, first of all, one thing we want to see here is, well, we definitely see it's already getting relatively complex, right? But also just look at what we've done today. Now that we have a baseline, adding features to this language is kind of shockingly easy, isn't it? I mean, we're adding pretty complex things to this, and we're kind of trucking right along. We're probably at the point in time now where we need to be pretty explicit about our variable names and things like that, otherwise we're going to start getting lost. Make sense? So,
It feels like it's getting easier and it's the one day puzzle.
Should you do a list
You've been
of?
watching a different class to try to catch
Oh yeah,
up.
he'll be watching this.
Yeah.
one, he'll
Yeah,
be
just to
watching
make
this
it the
one.
same.
so here's our list of arithmetic operators. And we're going to have less than, greater than, less than or equal to, greater than or equal to, equal to,
Not equal.
not equal to, those guys. All right, so let's just make this work for our, we're not going to worry about ands and stuff now. We'll just add one little feature at a time. So here's our list of arithmetic Boolean operators.
Naming conventions are falling off.
Are they? How?
Well, list of reserved words. It's the same naming convention.
Yeah, these are all the same. All right, so let's go down here to our we need to go to our parse. Here's parse. So right now we're asking, is this guy a Boolean? Well, I'm going to come in here and we're going to be looking at something that looks like this, right? So before this guy, so this guy is going to be similar to our if statement. Okay, so our if works like this. This guy right here works like that. That is, the car of this list is a less than. And what is a less than? A less than is a Boolean arithmetic operator. All right, we need to be able to do something with it. So let's look at how we handle the ifs in parse. So parse said, let's see, where do we say it here?
Eval.
All right, yeah, we're down here in, where am I in eval? Oh, sorry. Here's parse. Okay, so down here in this section here, if we're in this, so if we're looking at a symbol, so won't that guy be a symbol, less than? Less than will be detected as a symbol? Oh, it should be. I mean, it is the symbol less than, just like we had the symbol if before. So now we're asking, is it an op? If it is, do something with it. Is it a reserved word? Well, a less than is not a reserved word. It's actually a Boolean arithmetic op. So we need to add, define, Boolean, do we do hyphens? Arithmetic op. To this, and we're going to check on list of Boolean arithmetic operators.
It's swapped, isn't it?
Arithmetic Boolean operators?
That would have given a weird. That would have given. Did we spell arithmetic?
All right, so it's going to look for that guy in there. So we just wrote another, so this guy returns true if it's an op. This guy returns true if it's an arithmetic Boolean operator. This guy returns true if it's a reserved word, and false otherwise. I'm going to steal this guy here. All right, so we are inside of parse. We just asked, is this an op? If yes, do this. Is it a Boolean arithmetic op? If yes, list what do we call it? Let's call it a bool op. Called a bool arith op. That's the kind of guy he'll be. LC expression. So if we're looking at a symbol, if it's an op, make it an op expression. If it's a Boolean arithmetic op, make it a bool arith op expression. If it's a reserved word, Depending on which reserved word, make it the appropriate expression. Okay? Just running parse right now. So now we have our app expression. It's going to have an if. And this guy's going to contain an app expression whose first element is a Boolean arithmetic op, less than, whose second element is a lit expression, whose third element is a lit expression. So now we need to be able to evaluate Boolean arithmetic expressions. Make sense? And those guys come out to Booleans. I'm going to boil down to Booleans. So if I have that as my first element of an app expression, so these guys are always going to be inside of an app expression, what will the next two values be? What are my options for my next two values? I can ask it more easily if I scroll down here. Oh, I've already scrolled down. If this is an app expression, this whole thing here is an app expression, and the first element of this is a Boolean arithmetic operator, what kinds of animals are these guys? What must they be? What are my options? In this case, they're two numbers. They're two literals. But what could they be? Could they be variables? Could they be two var expressions that ultimately boil down to two numbers? Sure. So they could be anything that in our language is comparable, right? Right. So for us, are they definitely going to be two expressions that are evaluable? Evaluable? Am I saying that right? Yeah. And will there always be exactly two? Seems like it. So let's go up. We already have an eval. Let me press enter somewhere in here. Okay. We have something called eval op expression. We could create a secondary thing here called eval Boolean op expression. Let's see how we're detecting it right now in eval expression. So right here, we're saying if the first element is an op expression, then call eval op expression. So realistically, we probably want to go ahead and have a Boolean op expression just to keep this relatively compartmentalized. So let's rewrite this. We'll paste this guy in here. So this is a bool, what do they call it? Bool arith op. Did I not put express on that? Should be express. Well, no, I know I have it right based on what I said, but it's not consistent with what other things are. So this should be -exp. This is an op expression. This is a bool arith op expression. A little bit more involved. All right, so then down here, if it's a bool arith op expression, if that's the guy I'm looking at, then we're going to call eval bool arith op expression. Because the first element of app expression is actually a bool arith op expression. So I got to go write this guy. So this function is going to evaluate an app expression whose car is an arithmetic Boolean operator. So that is define eval bool arith op expression. This guy is going to be a lambda that's going to take in an app expression and an environment. And we'll go ahead and do our let. So let Op1 be eval expression CADR app expression. So that'll give me, in our case down here, 3. Op2 eval expression CADDR app expression. So that should give me the, in this case, what is that, 5? Yeah, 5. And then the op will be eval expression CADAR of app expression. Okay, so then I can do my cond. EQ the op less than, then we'll return less than op1, op2. Oh, I didn't, less than op1, op2, like that. Similarly, if it's less than or equal to op1, op2, greater than, op2, greater than or equal to, greater than or equal to, equal to, equal to, actually this is numeric comparisons, right? So that's just equal in scheme. Single equal sign is how we numerically compare two numbers, and we currently have a language of numbers. All right, so even though we're using kind of the Java symbol for that arithmetic Boolean operator, it's equivalent in scheme as a single equal sign for us to actually perform that operation. And then not equal to is actually going to be not that guy. Make sense?
What did you pass in there for the?
Same thing as we did for our ops. So we called eval op expression, well, eval bool arith op expression, passing it the cdr of LCE, so everything except app expression, except the word app expression. All right, so now let's kind of simplify this here real quick. Well, let's just make sure our parse still works. Do we have to compare it like this? Did we do that up here? Oh, we did. These all have to be quoted. Okay, so now let's go ahead and run this. Okay.
In your let.
Oh, thank you. Actually, is this going to be an eval expression? To get the op.
We shouldn't need it.
Well, we do need the op, but it's not an eval expression. What's the CADAR of app expression? All right. So if 3 is less than 5, boil down to 1. If 6 is less than 5, boil down to 2. If statements. If 6 is equal to 5, boil down to 1, otherwise boil down to 2. It's 2. If it's true that 6 is not equal to 5, boil down to 1. 6 greater than 5, we get a 1, so on and so forth. We got if statements. Wow. All right, so we have if statements based on mathematical stuff. So before we go and add, logical Boolean operators, I'll go ahead and add them as a thing up here. So we're gonna define list of logical Boolean operators. And these will be and or in our current world. Okay? And we're going to say not added to language yet. Just that's kind of a coming soon thing. All right? But could we say fairly that right now we have variables? So we have a way of doing memory. We have a way of asking questions. Now we need a way of doing repetition. Okay, so to do repetition, we're going to have to add another reserved word. So we can have multiple ways of doing repetition. Okay? But now that we have the ability to have a Boolean expression, couldn't we have like a while loop, for example? So we have a second reserved word. That's a while loop. Could we also have maybe a repeat loop? Do something so many times? A little bit of a different twist if we're kind of looking ahead. So just kind of thinking ahead what we might add. But we'll add a while loop first. So a while loop is going to start off by us being able to parse while loops, right? So here's our parse. If it's a reserved word, it must be one of these guys. So right now we only have one reserved word, which was an if statement. And now we're going to add another one, which is a while. Let's call this guy a while expression. All right, so we added that to our parser now. Parser knows how to handle while expressions. So let's give ourselves a guy here. So we're going to say while one is less than 110. Let's say something like that. Realistically, this probably needs to be I 10, something like that. What are we going to do? You know, maybe we boil down to plus I1, something like that. So now we have an app expression that is a while expression, and this while expression has within it an app expression. So the first element of this guy is a Boolean arithmetic expression, right? So we're asking, is the variable I less than 10? If it is, do this stuff. As soon as it's not, we're done. Make sense? Now, do we have the ability to modify the value of a variable currently?
Well, sort of. You kind of mentioned it, but Pat just was like, nope, forget about that.
Well, in our language. How are variables currently handled in our language? we currently have the ability to do what? How are variables generated in our language right now? How do we get variables in there? Give me an example of an expression here where a variable will be added to our environment. It's only one way. What's the only way that we can get variables added into our environment programmatically right now? Well, that's the behind the scenes thing that's happening in the engine. I need to write an expression right here that will ultimately call upon that. What's the only kind of expression I can write here that will add something to my environment? Who? No, I just said that's wrong. Something else in our code calls that. This is our language. This is the Amish language that I need to write. Amish language doesn't support extend thing for lambda. Amish language supports things like what do we support? All the stuff that's here in our parse. Okay, I have to write something that's parsable here. So here's parse. Where's parse? Parse? Here's parse. I need to write some expression that is parsable here. And there's no twist or turn here that's going to allow me to say extend DNV for lambda and make that work in there. Both are still wrong.
Oh, you can do some dirty cheating.
No, we don't need to do any cheating. We need to solve the problem in terms of the tools we have available to us. The tool we have available to us right now is, beta version 0.0001 of Amish language, right? How do I create variables in Amish language? Using a lambda. That's it. It's the only way I can do it. Along with an app expression. Correct?
Fine.
So we don't have that in our language. We didn't write it, but we didn't. Right now, we don't have that. So right now, what I can do is I can say lambda x 5, something like that. Except this guy needs to be in app expression. So I have a lambda working in conjunction inside of an app expression where I will establish a brand new variable in my environment. Under the hood, I will extend DNV for a lambda by grabbing a brand new variable x and associate it with a 5. That's the only way I can get a variable into my environment right now. In order for a loop to work, however, I probably need to have other ways of getting values into my environment. We'll talk about that in a second, but certainly for a loop to work, I need to be able to change the current value of a variable. If x is currently equal to 5, I need to be able to say x minus minus or x plus plus and have it update the value in our environment. Correct? All right. Well, so I don't have that ability. I don't have the ability to change a value in our environment. I also only have one way of getting a variable in my environment. How do we do this in Scheme? If I need to force an environment, and we've done this several times today, if I need to force an environment that has some variables in it and then do the next several expressions within that environment, what kind of animal do I use in Scheme? A let. Let's allow us to create local environments, right? So would it be helpful for us to create a let expression? Where a let expression is at least initially, a single name value pair, but probably a list of name value pairs. We certainly have the map to deal with that, don't we? Here's our parser. So it would be nice if I can do something like this. Let A5 B7. plus AB. That would be cool. Right? Go ahead.
In order for that to make, like you said, you were saying it's a list of named values, so would you have to have the A5 and the B7?
Oh, thank you. Yeah, this would be in a list. Technically, you could have made it work this way, but you're right. This is what I said out loud. So we had to pick a syntax. So let will take a list of name value pairs as well as the body for that to be evaluated within. Okay, so that means we have a new reserved word. Here, I'll put it before the while since we technically haven't written the while yet, but whatever. Then we need to add this to our parser. Where am I? So if it's an if, do this. If it's a let, make a let expression. All right, and then that let expression is going to contain, as it stands right now, when I parse it, what? What will this guy get flagged as? How will that parse currently? It's an app expression with what? App expression with two app expressions in it. So the whole thing's an app expression. This guy's an app expression, and this guy's an app expression. Correct? All right, so that's how it'll currently get parsed. So let's see that. So here's our app expression, whose first element is a let expression, whose second element is an app expression, whose first element is an app expression, whose second element is an app expression. And we could have 50 app expressions in there, potentially, right? Okay, so these guys are all app expressions. And for each of these app expressions, since it's a let expression, we want to do what? Extend our environment. Extend our environment. So we're going to extend our environment with this app expression. We're going to extend our environment with this app expression. Then what are we going to do? We're going to evaluate the body of the let expression in the extended environment. Does that make sense? So for your homework, update the interpreter so that things like this can be evaluated. This should give me a 12. Make sense? All right, so let's go ahead, before we forget, let's push this. Ooh, I just lose a whole lot.
I want that to be let, not if there.
Yeah, I just pressed. All right, we're back. Let's just make sure it still works. Yep, okay. So we saved this. Now let's go to the terminal, because we've been putting this up on GitHub, right?
Yep.
All right, and let's do history rep for 470 pound 660. That's this guy. Oh, that's fall 213. Pound 664. There's this guy. So we should already have a get there. So we'll do a get add star. Get status. I wonder what this guy was. That was just a sample one or whatever. Yeah, whatever. Then we're going to do a get commit -m added if statements and Boolean ops. And then history, grep for push, pound 677. All right, so now the guy's up on GitHub. There's the Amish programming language, this guy right here. And let's go into here. Is this going to be a good assignment? It's going to take hours. Weeks. Weeks.
Months.
Yeah, I don't think it'll take very long. Should be pretty easy. Let's see, this is 470? Okay. So, assignment is to add lets to eval expression and make them work.